questions 21 through 25 on the 2017 Grade 10 AMC 10B. In triangle ABC, AB is 6, AC is 8, BC is 10, and D is the midpoint of BC. What is the sum of the radii of the circles inscribed in ADB and ADC? All right, here is our triangle, and let's label it. We've got A, B, and C, and AB is 6, AC is 8, and BC is 10. And because 6 squared plus 8 squared is equal to 10 squared, this is a right triangle, so that is 90 degrees. And then they are saying that D is the midpoint of BC, so D is approximately here. That's D, and therefore this is 5 and this is 5, since that's the midpoint. And they draw a line, obviously, from A to D, and they want you to figure out the sum of the radii of the circles inscribed in these two triangles. So first, what we'll do before we talk about circles and all that, let's try to figure out what is the length of AD. I think that's definitely going to help us. Well, I can do that. One thing is just draw a line to the other side like this and a line going down like this. Well, since D is the midpoint, that means from here to here is half the distance from here, the entire distance. When you draw a line to meet BA, that means this will be half the distance of the entire side there, just like how the hypotenuse was. So if this whole thing is 6, this will be half the distance from there to there, so that's 3. And therefore this is 3. In a very similar way, when you draw the line here, this is half of the full distance, so this will be half of the full distance. So this will be 4, since that is 8. And therefore this is 4. So there we go. Now I can easily figure out that using Pythagoras. Since this is 3 and this is 4, AD squared is equal to 3 squared plus 4 squared. And therefore AD is 5. So there we go. So that's the easier way of figuring out those lengths. Now we get into the whole story about the circles. So let's draw in circles in triangles ADB and ADC. So there we go, there's the circles, and we also are going to have to put in some radii. So I will draw the radii to the tangent points, basically. And very similarly, this one from the center of the circle to the tangent points, like that. All right, and let's label this guy R1, and we'll call this one R2. And I'm going to have to draw in a few more lines to connect the centers to the vertices, and I think that should be sufficient. All right, so here we go. Now, let's concentrate first on R1. 1/2 base times height. If I look at this triangle, the base is 5 and the height is R1. Plus this triangle, 1/2 base times height. 1/2 the base is 5, the height is R1. You notice this is 5 and this is R1. And then added to this one, the base this time is 6 and the height is again R1. Now this whole thing, these three triangles, make up that triangle, which is ABD. And ABD, we know, has the sides 5, 5, and 6. And we also know this distance, that is 4. So we can calculate the area of ABD with 4 as the height and 6 as the base. 1/2 base times height, 1/2 6 times 4. So there we go. This is the equation that will allow me to figure out R. When I add all this up, I get 8 R1 is equal to 12, and therefore R1 is equal to 12 over 8, which would be 3 over 2. All right, got R1. Now in the very same way, I'm going to do R2, 1/2 again. Using this triangle, it will be 1/2 base, which is 8 times R2. Using this triangle, it will be 1/2 base, which is 5 times R2. And this triangle would be 1/2 base, which is 5 times R2. And then the area of this whole thing, we can use this as the base, which is 8, and this as the height, which is 3. So 1/2 8 times 3. So this therefore becomes 5 plus 4, 9 R2 is equal to 12. So therefore R2 is equal to 12 over 9, or 4 over 3. So there we go. I've got R1 and R2. They want me to find the sum, R1 plus R2. So that's 3 over 2 plus 4 over 3. And 3 over 2 plus 4 over 3 is 17 over 6. So number 21, the answer is D. The diameter AB of a circle of radius 2 is extended to point D outside the circle so that BD is equal to 3. Point E is chosen so that ED is equal to 5, and line ED is perpendicular to line AD. Segment AE intersects the circle at point C between A and E. What is the area of triangle ABC? Here is our diagram. Let's label this now. We got A, B, and D here, and C here. And then this is 5. This is 4. The radius is 2, so I guess the diameter would be 4. And then BD is 3. So, sorry, this is C right here, and this is actually E. Now let's join C to B like that. And as I'm sure you know, anytime you have an angle inscribed inside a semicircle, it will be 90 degrees. Now let's label a few more angles here. Let's call this guy theta. And then therefore, since this is 90 degrees, this in here will be 90 minus theta. And then in this triangle, since this is 90 degrees, this angle will be 90 minus theta. And as you can probably figure out, we've got a similar triangle situation here. So we will use that, but first let's do the very obvious, which is trying to figure out AE using Pythagoras. That's going to be 7 squared plus 5 squared. That's 49 plus 24, which is 74. So that means AE is root 74. And therefore, now we can use similar triangles. It would be this triangle being similar to the big one. And that means AB over BC is similar to AE over DE. Well, AB is 4. BC, I don't know yet. A to E, I just figured out, was root 74. And D to E is 5. So I can easily figure out BC. BC will be 20 over root 74. All right, I think I have just one more step before I jump to the area of ABC. I've got to figure out AC. And I think I can do that fairly easily using Pythagoras. So that would mean AC squared plus BC squared is equal to AB squared. So AC squared, BC is 20 over root 74 squared. And then AB is 4 squared, AB squared. So isolating for this, AC, when you do all the math, you will get 784 root over root 74, like that. And that is 28 over root 74. All right, we are ready for triangle ABC's area. It's 1/2 base times height. The base will be BC, which is 20 over root 74. The height can be AC, which we just calculated as 28 over root 74. And this looks like 280 over 74, which is 140 over 37. So number 22, the answer is D. Let n be 1, 2, 3, and so on, be the 79-digit number that is formed by writing the integers from 1 to 44 in order, one after the other. What is the remainder when n is divided by 45? This number, as you can see, is 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, then 11, then 12, and then so on, 13, 14, 15, all the way up until 43, 44, just in case you're wondering what that number is. Now, they want you to take that number divided by 5, 45 that is, and they're asking what is the remainder. All right, well, an integer is going to be divisible by 45, obviously, if it's divisible by its factors, which are 9 and 5. Now, there's an interesting fact that will help a lot in this question, that an integer is divisible by 9 if its digits, the sum of its digits is divisible by 9. So we have to figure out the sum of the digits of this n. And that shouldn't be too much of a problem. Sum of the digits of n. Well, you're going to have 0, 1, 2, 3, 4, 5, all those ... all the way to 9. That's going to appear definitely, and it's going to appear 4 times. One for the singles, one for the 10 to 19, and then 20 to 29, then 30 to 39. So 4 times. And then all the 10s will give you 10 ones, and then the 20s will give you 10 twos, and then the 30s will give you 10 threes. And then you have 40 to 44, so that we can just do that manually. 40 will give you 4 plus 0, then 41 is 4 plus 1, 42, 4 plus 2, 43, 4 plus 3, and then finally 44, which is 4 plus 4. When you add all these numbers up, you get 270, and this is indeed divisible by 9. So since 270 is divisible by 9, that means n is a multiple of 9. All right, so now that is established, now we turn our attention to n minus 9. N is a multiple of 9, so n minus 9 is also a multiple of 9. Now, if we looked at that number, n is equal to 1, 2, 3, 4, 5, ... If you notice, the very last numbers were 43 and 44. So n minus 9 is going to be some big long number, but we are interested sort of at the very end. It will be 4, 3, 3, 5, correct? When you're just subtracting 9. And this is divisible by 5, correct? Because it ends in a 5. And we are interested in the remainder when it's divisible by 45, which is 9 times 5. So since n minus 9 is divisible by 5, and n minus 9 is also divisible by 9, we can conclude that n minus 9 is divisible by 9 times 5, which is 45. So, if this number is divisible by 45, when you take this number and divide it by 45, it would give a remainder of 9, because this minus that, or 44 minus 35, is 9. So the remainder is 9, and therefore the answer to number 23 is C. The vertices of an equilateral triangle lie on the hyperbola xy is equal to 1, and a vertex of this hyperbola is the centroid of the triangle. What is the square of the area of the triangle? Here is a very rough sketch of the graph y equals 1 over x. And now we have to figure out how to draw this triangle. Well, I think that if I put one vertex here, one vertex here, and one vertex here, that should be sufficiently close to creating an equilateral triangle. So let's see here. It may not be perfect, but something like that. And now they say that the vertex of this hyperbola, which is this right here, this is a vertex, and that vertex is basically the point 1, 1. They're saying that's the centroid. So the centroid is where the lines meet like that. And those lines are basically the medians meet. The medians being the lines that cut the other side in half. And since this is equilateral, those are also the altitudes. So now that's pretty much all we're given in this question. We have to figure out what is the area, and then we have to square the area. Okay? Well, this point is also 1, 1, since it's also the vertex. So I can figure out the distance from here to here. So let's do that. That distance will be 1. This is -1, -1, by the way. So 1 plus 1 squared plus 1. It's minus 1. That's why it becomes 1 plus 1. So this looks like 4 plus 4, root 8. So root 8 is the distance from here to here. So let's put that in there, root 8. Now, if we know anything about 30, 60, 90 triangles and all that, we can easily sort of figure out the length of this height and then the length of the side. So I will draw that separately to avoid making the diagram messy. So here's this same triangle, but I'm going to draw in sort of the lines separately. There we go. Make these bisectors, and there we go. So since I know the distance from here to here, I want to get a relationship between the distance from here to here to the distance from there to there, and that will help me figure out the full distance. All right, well, let's just do some simple numbers, 1, 1, 2, and therefore since this is 90, this is 60, and this is 30, that means if I call top to bottom h, that means h over 2 is the equivalent of root 3 over 2. So h in this case is root 3. And now I can figure out the distance from here to here using a very similar 30, 60, 90. This time this is 30 and this is 60, like that. And we'll call this small h. So now h over 1 is the equivalent of 1 over root 3. And when you rationalize the denominator, you get root 3 over 3. So that means that if this is root 3 over 3, and this whole thing was root 3, then the distance from here to here is 2 root 3 over 3. So that means that this distance is double this distance. And that's essentially what I wanted to identify or establish. So we have figured out this distance from here to here in our triangle is actually root 8. So that means that the full distance from there to there would be, we'll call it h, big H, would be 3 over 2 times root 8. Correct? Because this is twice that. So you would take this and multiply by 3 over 2 to get the full distance. And that's something that is very important to establish. So this means that h is going to be 3 over 2 times 2 root 2. So that's 3 root 2. And then we can now figure out the side length of one of these guys. the side length h, let's just call it s. H over s would be the equivalent, using our 60, 30, 90 triangles. H over s, since this is h, would be the equivalent of root 3 over 2, using the fact that this side is 2 in terms of its ratio and this side is root 3 in terms of its ratio. So that means s would be equivalent to 2h over root 3, and since that h is 3 root 2, this basically becomes 6 root 2 over root 3. And we rationalize the denominator top and bottom by root 3, and therefore we get 2 root 6 for s. All right, so now we are ready to figure out the area. The area is going to be 1/2 base times height. The base is s, the height is h. So that's going to be 1/2 2 root 6 times 3 root 2. And that looks like 3 root 12. And then they want the square of the area. So the square of the area is square that. And when you square it, you get 9 times 12. And that is 108. So number 24, the answer is C. Last year, Isabella took 7 math tests and received 7 different scores, each an integer between 91 and 100 inclusive. After each test, she noticed that the average of her test scores was an integer. Her score on the 7th test was 95. What was her score on the 6th test? All right, there's 7 different scores. So that means the sum of all the 7 scores, the largest it could be and the smallest it could be, are as follows: 91 plus 92 plus 93 plus 94 plus 95 plus 96 plus 97. That's the smallest. And then the largest would be 94 plus 95 and so on. So adding these up, the sum is going to be 658 on this side and 679 on this side. And this sum must be divisible by 7, because remember, when you take the average, it has to be an integer. So if you take the average of 7 numbers and you divide by 7, that has to be divisible by 7 in order to give an integer. That's why we know that this sum has to be divisible by 7. Well, the only numbers that are in this range that are divisible by 7 are 658, 665, 672, and 679. Okay, so we narrowed it down to 4. But when we get to the 6th test, we know that since the 7th test was 95, the sum of the first 6 tests would be these numbers minus 95. So s minus 95 is basically going to be as follows: 563, 570, 577, and 584. These are the sum of the first 6 tests. Now this has to be divisible by 6, right? That's the only way you can get an integer. Now which one of these is divisible by 6? The only one is this one. So that means the sum of the first 7 must have been 665. All right, so let's talk about this. First set, second, third, fourth, fifth, sixth, and 7th. This is given as 95. And the sum of these guys is 570. And then the sum of these, the first 5, has to be divisible by 5. And the only way we can do that is to put here either 95 or 100 and test it out. You'll see if we put there 95, then you subtract from 570 95 and you'll get 475, which is indeed divisible by 5. If you put 100, you will get 470, and that's also divisible by 5. So this sixth number is either 95 or 100. And of those two, the only one listed in the answer choices is 100. And therefore, number 25, the answer is E.